So now we'll do a couple of examples. So we've got two functions and we're going to find their derivatives. So the first one, we've got y is equal to x squared times the sine of x. So let's start with that one. So I want to compute its derivative. And this is going to be a product rule, right? Because we've got two functions being multiplied, x squared and the sine of x. So we can write y prime, and let's apply the product rule. So we're going to have the derivative of the first factor multiplied by the second factor, unchanged. And then we'll add our second term, where we leave the first term alone, leave x squared alone, but we differentiate sine of x. Okay, and that needs to be differentiated, so I'll put a prime there. Okay, and now the rest is just taking care of these smaller derivatives now. So the derivative of x squared, we can use the power rule for that. So the first term is going to be x, or 2x, times sine of x, right? Because the derivative of x squared using the power rule is 2x. So we get 2x times sine of x, but then the other term, we're going to have x squared, which is left alone, but then times the derivative of sine of x. And remember, on the previous page, we just showed that the derivative of sine of x is cosine of x. So our second term, we're going to have x squared times cosine of x. And then that's all there is to it. So for that one, we've got our answer. That's going to be the derivative. You could factor out the x if you like, but it's not. There's no clear reason why you ought to, so it's perfectly fine to just leave it the way it is. For part B, well, what do we got here? We got f of x is equal to tan of x. And you might say, well, we didn't come up with a rule for the derivative of tan of x, so how are you going to do this one? Right? All we have is a derivative of sine of x and a derivative of cosine of x. And we got these two answers. Derivative of sine is cosine, and derivative of cosine is negative sine. So how are we going to evaluate the derivative of tan of x? Well, it's helpful to remind yourself that, well, what is tan of x? It's the quotient of sine of x divided by cosine of x. Right? And with that in mind, we can find its derivative using the quotient rule, because we know what the derivative of sine is, and we know what the derivative of cosine is. So we can use the quotient rule. So let's apply that. We can say f prime of x. Well, we're going to take the derivative of the numerator. So it's the derivative of sine of x, right? We're doing the quotient rule on this fraction. So the derivative of the numerator multiplied by the denominator minus the numerator multiplied by the derivative of the denominator. Okay, and then all of this is going to be divided by the denominator squared, because that's how the quotient rule works. Okay, so that's applying the quotient rule. Now we still need to take the derivatives of these smaller pieces, right? We need to differentiate sine of x, and we need to differentiate cosine of x. And we can do that using the rules on the previous page. Again, I'll remind you. So the derivative of sine of x is cosine of x. So this one here, this is going to turn into cosine of x. So we've got cosine of x times cosine of x for the first term. Now the second term, we've got minus sine of x, and then the derivative of cosine of x, remember, is negative sine of x. So we're going to use this second rule now to differentiate cosine of x. So we're going to multiply negative sine by negative sine. Okay, and all of this is still divided by cos squared of x, because we never touched that yet. Okay, and we can clean this up a little bit. This is really just equal to cos squared of x, right? Cos of x times cos of x is cos squared of x. And here we have sine of x times sine of x. They're both negative, so the negatives are going to cancel and disappear, but we really are going to have sine of x squared, or sine squared of x is how you normally write it. So sine squared of x in the numerator, and then our denominator, again, is still just cos squared of x. Now what? Well, remember one of those identities that we talked about at the very beginning. As a reminder, if I have sine squared of x plus cos squared of x, that just ends up being equal to 1. And that's exactly what you have here in the numerator. You've got cos squared. I mean, the terms are added up in the other order, but who cares? So you really have sine squared plus cos squared in the numerator, so that's really going to just be equal to 1 over cos squared of x. Is it wrong to not notice that? Like if I just cover that up and I stopped here and drew a red box around that and called that f prime of x, that would be true. It would still be correct, but what a lost opportunity, right? If you can give an answer in a much simpler form, you might as well. And it turns out that this is actually still not the standard way to write it. Again, this is perfectly correct, right? The derivative of tan of x is 1 over cos squared of x. That's perfectly correct. But typically, remember that 1 over cosine of x is actually secant of x. So it's standard to just write this as secant squared of x, like that. And that is typically what you would the way in which you would write the derivative of tan of x. Now, do you need to memorize this now? I mean, is it worth memorizing that the derivative of tan of x is equal to secant squared of x? You don't absolutely have to do it, because you can always just write tan of x is equal to sine of x over cosine of x and do the quotient rule. But this is a fair amount of work, right? And if you have to interrupt a larger, more important process to stop and work these details out every time you encounter a tan of x, you might end up spending more time than you want. Plus, there's a lot of room to make a mistake every time, right? And you're still going to have to memorize that the derivative of sine of x is cosine of x, and memorize that the derivative of cosine of x is negative sine of x, unless you want to be prepared to work through this, or to work through these calculations every time you want to check the derivative of sine of x. So some things are just worth memorizing. So I would say memorize that the derivative of sine of x is cosine of x. Memorize that the derivative of cosine is equal to negative sine of x. Those are definitely worth memorizing. But also, it's worth memorizing that the derivative of tan, which I'm going to put this in a separate box here just so it stands out a bit more. And I would say if you have a formula sheet, definitely add this one to it. The derivative with respect to x of tan of x is equal to secant squared of x. Okay, and again, you don't absolutely need to memorize it, but it sure makes your life easier when you're doing this stuff if you do have this memorized. So I highly recommend memorizing this rule. You could, in a similar fashion, you could actually derive rules for the derivatives of all the reciprocal trig functions, like secant of x, cosecant of x, and cotangent of x. And actually, that's one of the things I will get you to do on the suggested exercise sets. So you can once you do those exercises, you can add those to your formula sheet as well. But I won't include those here. Okay, so that takes care of that example. We've got another example on the bottom half of this page. Find the equation of the tangent line to the graph of y equals x times cosine of x at the point pi, x equals pi over 2. Okay, so this is just another one of those questions, right? We're asked to find the equation of a tangent line to the graph of a function at a particular point, right? That's nothing new. The only thing that's a little bit new now is the fact that our function has some trig in it. But as long as we know how to take the derivative of trig functions like sine and cosine, which we have rules for now, and tan as well, there's really nothing that's going to change about your general process. This won't feel like we're really doing anything new. We're just using a new differentiation technique or a different differentiation rule. Okay, so let's start by taking the derivative, right? Because we need to get the slope of that tangent line before we can even start writing down its equation. And to do that, we're going to need the derivative. So we want to start by finding the derivative. So I'll write it as y prime. And what rule are we going to use here? We've got a product, right? X times cosine of x. That's two functions being multiplied. So we're going to take the derivative of x and multiply it by cosine of x. And then for the other term, we're going to take x and multiply it by the derivative of cosine of x. That's just writing out the product rule and nothing else. Now on our next step, we'll take care of the details, these smaller pieces. The derivative of x, that's just x to the 1. Use the power rule on x to the 1, and you just get 1. So we'll just have 1 times cosine of x, and then the derivative of cosine of x. Remember, if you've forgotten, just check your formula sheet, check the previous page. Derivative of cosine of x is negative sine of x. So, great. We're going to have plus x times negative sine of x. Now, if I clean this up a little bit, I'm just going to get cos of x minus x times sine of x, right? Because that 1 doesn't do anything, and that negative can come out in front. So that's our derivative. Now what about our slope? Well, the slope, you can write it as, if I write m equals, the slope is going to be given by the derivative at the particular point in time when x is equal to pi over 2. All right, so if I plug in x equals pi over 2, to y prime, which is cosine of x minus x sine of x, I'm going to get cosine of pi over 2 minus pi over 2 times sine of pi over 2. Okay, and don't now reach for your calculator, right? We know these values. Pi over 2, that's the first place where cosine of x is equal to 0, right at x is equal to pi over 2. So this is equal to 0, and sine of pi over 2, well, pi over 2, that's right where sine hits its first peak. So that's equal to 1. So really, what you have here is just, well, 0 minus pi over 2 times 1. So it's negative pi over 2. Right, so I want to just remind you, I'm not just pulling this out of nowhere. If you remember the graph of sine of x, right at pi over 2, that's where it hits its first peak of 1. Right, so that's worth remembering. Remember the graphs of sine of x and cosine of x. And in a similar fashion, you can remind yourself that pi over 2 is where cosine hits 0 for the first time. It's the first quarter of a sine wave, and that's right where it hits the x-axis. This is the graph of y equals cos x. Okay, so don't forget the graphs of sine and cosine, because they can come in handy in situations like this. Okay, so that gives us our slope, negative pi over 2. But what about the equation of the line? To get an equation of the tangent line, we need more than just its slope. We need a point that the line goes through. And, well, certainly we do have a point where the line goes through. Well, we just don't know its y-coordinate, right? We're talking about the particular point on the graph of this function whose x-coordinate is pi over 2. But we're not given the y-coordinate. And that's okay. We can get the y-coordinate by simply just plugging the x-coordinate into the function. So let's write it out this way. Our x naught, which is the x-coordinate of the particular point on our graph, or that the line is tangent to the graph at, is pi over 2. So y naught is just going to be, well, what do you get if you plug pi over 2 into this function? So we're going to get pi over 2 times cosine of pi over 2. And again, we actually just talked about this. Cosine of pi over 2 is equal to 0. So it doesn't matter if you multiply it by pi over 2, it doesn't matter, it's still going to be 0. So our y naught, for the purposes of the point slope formula, our y naught is equal to 0 and our x naught is equal to pi over 2, and that's all we need now to finish this. So I'll just slide this down to the bottom. We can say, therefore, the tangent line is given by, well, we can say y minus 0, because it's y minus y naught, is equal to negative pi over 2 times x minus x naught, and x naught is pi over 2, so we're going to have x minus pi over 2. And many people might wonder when they see this, do you really need to go y minus 0? Is it really necessary to write this? No, it's not. You can omit the 0 and just write y is equal to negative pi over 2 times x minus pi over 2. Why am I bothering to write it like that? I just want to make it fit in exactly with point slope form. So I'm going to the effort of actually exaggerating that y coordinate at that point, but it's not mandatory. And it's not even mandatory to use point slope form. You can also use slope intercept form. That's perfectly fine as well. Okay, so that completes that example. That gives us the tangent line we were looking for, and that's that.